So this is the final private pitch for the Deep Tech Climate Innovation Challenge, which is presented by Extreme Tech Challenge and sponsored by Cadence, and in particular the Charitable Foundation for Cadence Design Systems. And we thank them very much for their sponsorship and for initiating this very interesting collection of startups. We are down to 8 finalists who are going to be presenting today. And this is just in alphabetical order. 7 Analytics from Norway, which is doing flood prediction. Barrow Green from Washington, D.C., which is a next generation refrigeration play. BioEsol from Mexico, which is a grid storage play. DAC from Poland, which is another refrigeration play. EarthN from Arizona, which is another grid storage play. Group from Switzerland, doing hydrogen fuel cells. CO2 from the Netherlands, which is a capture and sequester play, and Water Warriors from Kentucky, which is a clean water play. So you can see it's a variety of topics all around climate innovation and deep technology. One of the, I think, cornerstones of XTC is that we are presenting these startups to an absolutely top shelf Davos grade level of judges, which we have arranged here today, and we're very pleased to have all of you join us. And again, this is just in alphabetical order. I'm going to start with Jaswinder Ahuja, who's Corporate Vice President for International for our sponsor, Cadence Design Systems. We're also very pleased to have judging with us today, as well as being a keynote speaker at our event next week in Las Vegas, Dr. Vanessa Z. Chan, who's Chief Commercialization Officer at the U.S. Department of Energy's Office of Technology Transitions. Next from NXP, who's one of our founding sponsors, Adrian Hernandez, Director of Strategy for Integrated Solutions, who works in the Chief Technology Office headed by Lars Rieger, who's one of our board members. Next is my former boss at Samsung, Francis Ho, who's now partner at Walden Catalyst Venture Fund. Next, Nicole Johnson, Global Director of Social Impact, again at Cadence Design Systems, and Nicole has been our primary liaison in setting up this event. And finally, Andy Cow, also a partner at Walden Catalyst Fund. And let me take just a minute, Nicole, if you're on, and yes.
Yeah, absolutely. Sorry, I'm not on.
No, it's all right. But
I'm at the tail end of COVID, and so I'm just not feeling ready. But
sorry about that. But do you want to just say a few words about your undertaking this endeavor?
Yes, absolutely. So thank you. So we are really excited to be sponsoring this, and thank all of the participants for joining us in this. It's really exciting. Our foundation is one of our key focus areas is on the issue of climate change. And so we're really excited to see these amazing solutions and the work and projects that so many of you have done and put together to address this issue of climate change. And so deeply grateful for your commitment to this work as well. And really excited to see and meet some of you next week and continue this work today and in the future. So thank you. And a huge thank you to Extreme Tech Challenge for all of the work that they have done to put this together, the logistics, and just ensuring that we have such high caliber startups to discuss this with. So thank you.
And Victoria, I know you're just watching this morning, but do you want to say a couple words?
Yeah, I just want to add on to what Nicole said. First of all, just really grateful for the partnership and sponsorship of the Cadence Foundation. And also thank you to the team, John, Nancy, and Shale, Socorro. You guys done a lot of work to arrive today at this fabulous batch of companies. So, and again, thank you for all the startups who have participated. And I look forward to seeing everybody presenting on stage at CES next week. And of course, I want to thank our judges for spending time and expertise to help us find the most deserving companies of the global stage. So thank you.
Okay, so quickly going through the evaluation criteria, which has been our standard criteria throughout XTC. I'll start at the bottom there. Tech for Good is, of course, the foundation of what we're doing. The degree and reach of human impact on human and planetary health. But our main thrust, and this has been throughout XTC, is that these startups should be ripplingly good investments. And not just because that's a nice thing to have, but our whole premise is that the idea of global impact for better human and planetary health is no longer necessarily a cost drain, but can actually be a good, solid commercial investment. That part of sustainability is economic sustainability, and if you're going to have a global impact, you need to have scale up. So our primary criteria, and these are equally weighted, are the standard things that any investor would look at. Is it a good and credible team? Is it a really innovative and defensible technology? And do they understand where they fit in a market that can really scale up globally? Those are weighted equally in the run-up to this. And then today, the judges are going to be looking at all those aspects in coming to their final evaluation. So the pitching order, again, and also because there are no two extreme time zones, we're going to just take this in alphabetical order, starting with 7 Analytics and going through, ending with Water Warriors. So I believe it's Jonas from 7. If you're presenting, if you could, in just a second, I will unshare, and if you'd bring up your slides to share. Let me stop sharing now and get you prepared for that. And I will mention while you're bringing those up that we're actually making these folks pitch 3 times to earn their keep. They're pitching today and then twice next week, mostly in person or by video. At CES, they're going to be pitching on Wednesday at a private reception held by XTC and sponsored by Cadence at the Venetian Expo Center, which will be an invitation-only event for very top-tier investors, and then a public event on Thursday the 11th at CES in their Eureka Park Startup Small Business Innovation Zone called Eureka Park. And it is on Thursday the 11th that we will actually announce the winners. We're not going to announce the winner today. We'll be deciding that today or later this week, but we'll announce it on Thursday the 11th for publication. So before we start, are there any questions or comments? Oh, I should say that the format is, per usual, it's a 2-minute pitch, 3-minute Q&A. Any questions or comments? Oh, I should also ask, do all the judges, have you found your score sheet? It should be, it's a Google sheet that should be linked in your calendar invitation.
Yes, I have.
Anyone not have it? Okay. So with that, when you start, I will start the timer, and we'll start with 7 Analytics.
Yeah, hello. Can you see my screen and hear me?
Yes, I can see Exploring Future Landscapes.
Perfect. And it's not Jonas, it's Werner Svellingen. I'm the CTO of 7 Analytics who's going to do the presentation. So then we are ready to start.
Yes.
7 Analytics has risen as an innovative force within the climate tech sector, with clients benefiting from our solution all around the world. From our Norwegian roots, we bring a diverse blend of expertise in earth science, data analytics, and software development to tackle the pressing climate issues. Tripling urbanization last decades had disrupted water absorption from natural landscapes, hence escalated the flood risk. Additionally, climate crisis is rewriting the norms, with once-in-a-century floods potentially becoming an annual event. These megatrends are on collision course. No, resilience is no longer optional, it's mandatory. In the US, flood damage have tripled from the first to second decade of this century, and towards 2030, damages are expected to triple once again. In Europe, only a quarter of flood damages are insured. Hence, the future will be costly and innovation is needed. The true sustainability equals effective climate adaptation. Devastation wrought by flood extends beyond the visual damage. It challenged the very fabric of financial security when insurance companies withdraw from the market and the coverage wanes. 7 Analytics deliver flood risk intelligence to insurers, allowing them to stay in the market regardless of geographical location or asset value. InsureFlood monitors 250 parameters related to the physical environment of each property, providing detailed insights into flash flood trajectories on which insurers can price their products with precision. The model's validity stems from a machine learning algorithm trained on data from millions of buildings, refined by proprietary geospatial datasets along with historical flood claims. InsureFlood serves as a threefold force, enhancing risk understanding, ensuring pricing precision, and fostering proactive prevention. So by that, we're hoping that to transform the climate uncertainty into strategic actions. Thank you.
Okay, very timely. Challenging questions from the judges.
Go ahead, please.
I just had a question on the sources of information, right? Because the AI model or technology you've developed is really going to be based on the information sources. Other than the, I guess, national weather, inputs that you're talking about, have you worked with any other major, let's say, weather station company, independent weather station companies that are that you can provide sourcing from?
Yeah. So we kind of have a plugin model for the weather sourcing, but that's not the kind of the key input because that's more for the prediction model that we have. But for the insurance, it's more the big insurance company. So we have been working with to get claims, historic claims from a lot of companies, insurance companies around the world, and use that into the model. That's actually one of the key inputs and one of the really hard thing to get.
So you're talking about historical data then?
Yes. And then we use that into the prediction model. So we train them on it. So it's a kind of, so that's one of the key elements when doing environmental analysis is to get historic events.
And how do you get paid? So you mentioned you have 40 plus customers. What is your monetization model?
Yes. So for this one, the insurance companies, they actually pay annual fee for this product. We also have other products, but for this one, there's an annual fee that they use either for based on number of buildings or they have or kind of a license for free use.
And how much is that annual fee?
It varies, but it's $100,000 plus.
Are you getting paid right now? What's your current status?
Yes. We have several customers for this, and we are now going in Europe and US to get more customers.
And then how do they use your data? So they're using it then.
Oh, they use that varies. Some are using as they send a building ID, and then we reply the flood risk based on that into the API they have. But someone is using the data directly into the pricing model towards the customers. That's the most common thing. So they use it as repricing. Yes.
Are you also selling to government, cities, like?
Yes.
Okay.
Yes. That's more early warning systems.
So there's other companies that are doing similar things. What makes your team distinctive from others in the market?
Yes, there is companies doing sort of the same things, but from what we have actually seen now is not that many competitors doing exactly the same thing and have access to this data and kind of manage to merge them. I think the uniqueness, if you ask me, is the kind of the amount of data that we put into the learning model.
Any others?
If I then can add one thing that I hope that
Sure.
this can kind of open it up for, I mean, since it's climate for good or whatever, I have a long experience from Africa and so on. To this kind of financial impact, to kind of use that into Africa, to other kind of developing countries, is kind of one of the key elements that we hope that we can kind of provide for cheaper price, and also kind of to where they should kind of build and to avoid kind of damage in the future. So we hope that the scalability is also for that.
Okay. Thank you very much. We'll take a moment for judges to mark up, and then if we can have Barrow Green, if you can unshare, and Barrow Green, Daniel, you can bring up your slides. Thank you. Okay, are the judges finished marking? Looks like you're all heads up. So with that, we will start with Barrow Green. Please go ahead.
All right, great. Thank you. Good morning. I'm Dan Levick, the engineering director at Barrow Green, where we are developing elastocaloric solutions for a warming planet. Now, survival on a warming planet requires cooling of our living spaces and of our food. But modern cooling technology actually makes the problem worse. It's inefficient and it releases powerful greenhouse gases into the atmosphere. More cooling causes more warming, which requires more cooling, a vicious cycle. Our solution is elastocaloric cooling, which uses solid refrigerants, so no greenhouse gases, that are non-toxic, non-flammable, and 2 or 3 times more efficient than current technology. Previous attempts to implement elastocaloric cooling use large, expensive hydraulic presses. Our approach uses small, inexpensive electric motors, which allows us to address markets ranging from residential AC, refrigeration, vehicle AC, and even personal cooling. Each of those markets is covered by our partially exclusive license and has a market size exceeding $1 billion. Our business model will be to sell cooling units to OEMs, starting with consumer wearables and PPE. We expect it to take 2 years and about $2 million to develop a saleable wearable, and an additional 4 years and $4 million to scale the technology to vehicle and residential window-sized AC. Our CRADA, Cooperative Research and Development Agreement with the Army Research Lab, has allowed us to collaborate with the original inventors of this technology, and we've all been hard at work this past year. In May, we delivered a prototype to the US Army. We have responded to several government solicitations in partnership with elastocaloric cooling experts at Ames National Lab, and we are about to launch a NASA-funded project with University of Illinois to put this technology into space. At Barrow Green, we aim to stop the vicious cycle and keep our planet and its inhabitants cool. Thank you.
Okay, right on time. Judges.
Daniel, if you could leave your first slide up there.
Sure thing.
Thank you. Yeah, that one. Thank you. Sorry, not this one. I mean
The
next
the
one.
first next one.
Oh, yeah.
First,
That one.
content. Yes.
Okay.
So have you actually created a product yet?
No.
Yeah.
We are kind of a pre-seed stage in terms of development. We're working on our core technology and responding to bids, especially for government funding.
So the mechanism for this is electrical. Can you talk a little bit about the efficiency level for this?
Yeah, so it's elastocaloric, so it has a solid refrigerant, and the way you get cooling out of that is you apply stress to the solid that causes it to heat up, and then you reject that heat to the environment. You remove the stress, it cools down, and you can absorb heat from your room or your refrigerator or whatever. The efficiency that we're expecting for something like a vehicle air conditioner is around a coefficient of performance of 5. So 5 watts of cooling for every 1 watt of input power, which is about double what a vapor compression current technology air conditioner would be.
Can you talk to me a little bit about the economics of this for someone who needs to buy this? Because currently, air conditioning, things like that are pretty inexpensive. So have you had a chance to do any economic analysis to understand how this compares to current solutions?
Absolutely, yeah, and it compares favorably. It's competitive with vapor compression. We put together one proposal for a portable, like window-sized air conditioner, and had a product selling for under $300. So we don't need some of the more expensive components of something like a window air conditioner, copper tubing, high pressure tubing, a compressor, things like that. And the refrigerant that we're using is commercially available. So there's already a manufacturing base. So it's not a high cost item.
And the $300 is at what scale? Like how many things do you have to be cranking out?
So that'd be probably at tens of thousands, by scale.
Are you looking at a specific market to hit this with first? Is it US or is it global? Where are you looking?
Probably US, just because that's where we're based.
And why is NASA putting this technology into space?
So it has the potential to be both compact and lightweight, more so than other cooling technologies. And so those are two things that NASA is very interested in. And of course, keeping humans cool in space is important. So they're some of the foremost experts actually of elasticaloric cooling, this technology, are at NASA. So it was really validating for them to kind of pick our approach for further development.
And is it going in in a suit, or is it going in a physical space?
So it's early stage enough that we would hopefully be developing it for both. Yeah.
Is part of your strategy, though, I think I heard it in your in the beginning, more on the wearables, where I think I met you at Disrupt, and you shared, I think you have military background, and you shared that on the military applications this would be very helpful on the fields.
Absolutely, yeah. So that was our CEO, Greg Stroud. He was in the Special Forces, and yes, the wearable and personal protective equipment market doesn't have a great solution using vapor compression or existing technologies. So our ability to be lightweight, compact, highly efficient lets us have a high runtime on a battery and build something that's small enough that someone can carry it around for a reasonable amount of time with low effort.
And you've developed a prototype for that specific application, or?
Not for that specific application. We're still focusing on building a small, efficient kind of core module.
Okay, thank you.
Sure, thank you.
Okay, if none others, we'll take a pause for scoring while we have one of the areolas to bring up their slides for BioESOL.
Yeah, one last question, sorry.
Oh, go
Maybe
ahead,
you said
Francis,
it already.
please.
What is the time frame for you to reach that very first commercial kind of sale? How long from now?
2 years.
Okay, thank you.
Hello, are you
Yes.
seeing my presentation?
Yes, we see that. Enabling energy autonomy. You are powerful.
Perfect. Hi, everyone. I'm Alejandra.
Hold on
co-founder
just a second. I'm going to give a couple more seconds to make note, and we'll start about 20 seconds.
Dakar.
Okay, if everyone is scored, we will start with Alejandra.
Hi, everyone. I'm Alejandra, co-founder of BioSol. Here is a question. What are the two biggest challenges the world is facing right now? I'll give you a hint: energy and climate. This is where BioSol comes in. We believe that one of the biggest growth opportunities in history lies in the storage and management of energy. And that is our solution, a revolutionary battery solution with a world-first energy intelligence software. Our battery efficiently stores energy from different renewable sources, and its versatility is reflected in multiple configurations that enable users to maximize the use of 100% of generated energy. In addition, our battery features an innovative auto-balance cell system that ensures that if a cell experiences an issue, our battery will keep functioning. To complement our battery, our software empowers users with key insights for informed decisions on efficient energy use. Our technology is truly amazing. Let me tell you why. First, we doubled the lifespan of our battery. That means more than 25 years. Second, our batteries function without any interruptions, not even microseconds. And last, we supply electricity as direct current at 148 volts. To speed up our innovation strategy, we have opened an R&D office in Grenoble, France, leveraging cutting-edge technologies. Did you know that the world needs 970 gigawatts of battery storage to achieve net zero, and today we only have 28 gigawatts installed? We are talking about the global market value of $200 billion. Like industry giants before us, we are leveraging a unique business model that covers gaps other players don't meet, focusing on small and medium businesses. Here is a good example of how our solution reduces energy costs and CO2 emissions. We are a proven B2B continuous energy solution. We started operations in May 2021. Last year, we surpassed the $3 million in revenue with a pipeline of $140 million, being profitable since year one. We have been backed by relevant investors and signed up strategic alliances with recognized corporates. To make this happen, we have gathered a world-class team to build the world-leading battery storage company. Thank you very much.
Excellent. Okay. Questions?
So are you doing a BMS or are you leveraging somebody else's BMS?
Micro to the CEO of BioSol, Felipe Arreola.
Yes, can you hear me? Perfect, excellent.
Yeah.
Thank you. Nice to see you. Yeah, we developed the BMS also, so all the technology was developed in-house.
So this is all the software from just raw cell, battery cells to system level, higher system level software?
Yeah, exactly. We develop all the software, installing the controller, the energy management system. So all the software and the hardware was developed or is being developed in-house.
And what's the battery made of?
Right now we're using lithium ion and as well lithium ferrophosphate. But in our roadmaps includes to start some trials with zinc and iron as well.
And how much does the system cost to someone?
Well, yeah, so we are on an average of 500 per kilowatt per hour. So we are pretty much on a competitive basis. Our system comes from 2 kilowatt per hour to 1 megawatt.
And what's the capital outlay in the beginning?
Well, it depends. So if customers wants to buy a one-time self solution, well, we are going to install everything once that the client pays us 80% in advance, and we are going to install everything. So they are going like 10 kilowatt per hour. That they are going to pay us $5,000 in this case for the battery. If they don't have solar panels, we also can offer an integral solution that is in the one-time solution. And on the other hand, in the energy as a service solution, they don't have to pay us anything, so they only have to sign up energy contract, long-term contract, so they only have to pay us a monthly subscription fee that is going to be lower than the current energy bill.
So if you compare yourselves to integrated systems such as Enphase or Solar Edge, How does this compare to the offerings that they have?
Yeah, for sure. So we know them pretty well. So first of all, we offer like them an all integral solution, but we are focused on small video businesses where we find out that there is an underserved market, mainly on the Latin American and and now we find out that in Europe. Additionally, there is a huge market, example in Germany and France and Spain, where small and medium business doesn't have this kind of solution, this kind of energy as a service solution. So the energy as a service solution is a PPA plus battery. So we understand that they are pursuing the residential area. So we think that we can have a bigger impact on the small and medium businesses.
So if you go back to your grid that you had with the competitors, you were the only one in the top left quadrant. Do none of the other players play in that area?
Yeah, exactly. So that is where we are focused on the small and medium business sector. So other players and in this quadrant, we are trying to reflect that we are offering something that there is no one at this moment that is offering this energy as a service model for the small and medium businesses. So other players are offering only one-time sell a battery for the companies, but no one is offering this PPA plus battery.
And what would prevent people from moving to that quadrant from where they are today?
Well, in this case, our competitive advantage, all the barriers lies on the technology that we developed. We have already three patent files. One of them is regarding the lifetime of the battery. So that means that if a company acquires one of our battery, they are going to obtain the double if we compare it with other batteries that are in the 10 to 12 years lifetime. This is one of them. The second one is the auto balance cell system. That means that there is a issue with one of the cells. Our battery managed to function and to keep running the battery, even that issue with the cell, and other battery shut down in order to protect all the electronics in the battery. So we have competitive advantage, and well, we understand that in order to be competitive, we need to speed up our innovation. That is the reason that we opened an R&D office in France last May with the support of the French government.
Okay, that should be our time. Thank you very much. And if I believe next, Pavel, if you once they, was that a comment? No.
No.
If you can unshare the slide by Isol, and then there, and then Pavel, if you can bring yours up while we take a judging break for the judges to score. By Isol. Excellent. Seeing your slides. So just another few seconds. Okay, everyone looks like they're done. So Pavel, if you would proceed with dynamic air cooling.
Yes, thank you. So I just would like to make sure that you can hear me all right.
Yes.
Yes, okay, perfect. So hi, my name is Pavel, and today I would like to talk to you about something really cool, and that is, of course, about cooling. Maybe you know that the United States of America use more energy just to cool down buildings than the entire continent of Africa on everything. However, the very same technology will cause, okay, my screen is frozen. The very same technology, yeah, okay, perfect, will cause 27% of global warming by mid-century, mainly for two reasons. First, cooling uses loads of electricity, and second, used HFC freons are super greenhouse gases. Therefore, Montreal Protocol says we have to replace 85% of such devices by 2035. And we have created a breakthrough approach to cooling. We have developed a technology which can drop down air temperature by 90 degrees Celsius or 150 degrees Fahrenheit, uses significantly less electricity, and as a result, we can cut down greenhouse gas emissions from refrigeration by 50%. And this is how we do it. This is our device. We cool down a large food storage chamber where previously 4 times larger Freon-based device was installed. Of course, on this market, there is plenty of competitors. However, what is important to remember that none of them is able to deliver the same range of temperatures and cost of cooling as we are able to provide. From our point of view, we focus on cold chain market. That is the segment which is worth nearly $94 billion, and we develop solutions for food storage and refrigeration. And in order to bring our technology to the market, we have defined 3 go-to-market space. So first of all, right now we are at the stage of commercial pilots on selected beachhead markets, and these are our customers. Then we replicate and outsource the production. And finally, we plan to scale up globally also through licensing. We are happy to be supported by European Union, and we are looking for additional investment for technology validation and high-speed market entry. Our team is absolutely sure that we are able to deliver. We are also proud to be supported by top advisors. And here, together with you, we hope to make things a little bit cooler. Thank you.
Okay, judges.
So what is the cooling technology used here, and how is it different from regular compression cycle cooling other than the use of a different refrigerant?
We don't use any refrigerant. We use just air, hence the name dynamic air cooling. And the technology or the principle behind it is recuperation of thermal energy which is contained in the air. Due to the compression and gas dynamic cycle developed by our CTO, who is the author of this invention, we are able to decrease temperatures, as I mentioned, by 90 degrees Celsius, which is pretty low and pretty remarkable for quite low pressures we use in our cycle. And that is up to 3 bars only.
So have you tested this with, you're going after the cold chain market. And so like the Walmarts and Sam's Clubs and all those of the world who are the ones that use the most energy in order to do the cold chain. Have you spoken to them and understood what it would take to displace their existing facilities in order to use your technology?
Absolutely. We have conducted over 70, I believe, customer discovery interviews right now with our clients. And our goal is to talk and to target specifically companies who are big players on the market. So therefore, we speak about industrial refrigeration. And from that perspective, they have 2 key driving factors. One of them is electricity saving per unit of cold. And the second is CO2 emissions or green image of the company. And that starts to play gradually more and more significant role. So as we continue these discussions, there is a number of companies who are waiting for our solution, and they specifically requested to build a unit which they can test in their environment.
So the customers I saw were people that would actually be end up selling to the Walmarts or the supermarkets and all that. The list of customers you have there. I look at Sainsbury's as one, which is a store. And so just want to understand a little bit, around maintenance and other things like that matter to these retailers, downtime. So when you look at kind of the total cost of ownership, including electricity savings, the carbon dioxide savings, talk to me a little bit about how you're differentiated compared to what they have today.
I think you hit it on the nail. So our goal is to deliver lower total cost of cooling, and that, of course, consists of two parts. First, capital expenses, which you have to have at the beginning to buy this equipment and install it. And second is running. So our strategy is to offer the same initial cost, however, to provide savings over a longer period of time in operational expenses. And this is where our technology is able to cut down electricity costs by 50%. And of course, we don't speak about costs related to freon replacements. Right, so there is a very interesting notion which is known as chronically leaking device, and this chronically leaking in terms that it leaks freons, and freons have to be replaced. And this is especially true for customers like you mentioned, so big grocery chains and retailers. They have a significant portion of their costs related to refrigeration going into this particular type of expenses.
Is your proprietary way of compressing the air, is that limited to inside your box, or do you need to expand to the room, and how much noise and disturbance does it cause?
Well, speaking about the compression, we don't invent anything there. We just selected the type of air compressors which are readily available on the market and which can be adjusted to our purposes. And this is what you see on this picture. There are, as a matter of fact, three different compressors, three different units, which are currently being in tests. There, the level of noise corresponds to the level of operation of standard air compression equipment, which is about 70 decibels. Of course, we understand that this is not suitable for residential purposes, but on the other hand, I didn't meet a human yet. I didn't meet a human yet who will require temperature delta of 150 degrees Fahrenheit in their home. So therefore, we say that this is for industrial purposes where this level of noise is acceptable.
So if you are using off-the-shelf parts and all that, what prevents someone from coming in and copying what you're doing?
Air compression is just the first stage in the cooling process. Everything else is developed by our team, and the IP is fully belongs to the company.
And how much IP do you have?
We have currently already several patents which we received. We are already in the process of patent in PCT for European market. The patent application is already sent, and also we have patent applications in United States, Japan, China, and South Korea.
And you mentioned cold storage chain, and so that's got a lot of mobility in it. Is there applications already being targeted for, trailers and those containers that move the food products that needs cold storage?
Absolutely. One of our clients is Maersk, and they have 600,000 shipping containers, 1/3 of worldwide fleet. And from this perspective, we already discussed and we designed a unit which can be suitable both for refrigerated container and trailer. And one of the companies on this list, Wilton, this is a Polish producer of trailers. So we are working together with them to build a zero-emission refrigerated trailer.
That was my question. If you were going to license this type of proprietary IP to companies that have focused products in that market and serve that market, and you can drive that through them directly instead of going yourself and trying to build those relationships. So, okay. Are they an MVP then? You're saying they've already started working with you on a product?
Yes, absolutely. So you're absolutely right. We have big plans, but we also have a solid realization that we are just a startup. We probably will not be able to compete with big players on the market, like some of the names you see here on this slide. So therefore, from this perspective, we would like to make them our allies, and together with them, bring this technology to markets where our direct market entry would be highly problematic. Like, for example, Japan. We know very little of Japan. It will cost us tremendous amount of money to build and establish distribution, supply, production, service infrastructure in Japan. So from this point of view, we're looking for local partners who can bring this technology to market and profit together with us.
Okay, that if nothing else pressing, that should be our time. Thank you very much. And Pavel, if you can unshare, I think Mr. Chakravarti is up next. If you can share and bring up your video while we take a scoring pause for the judges. I see video and slides, so a few more seconds. Okay, looks like everyone should be about done. So next will be Karthik Chakravarti from Earth N. Please go ahead.
Hi, thank you. Globally, we're moving towards solar and wind as our main forms of electricity generation. However, solar and wind are intermittent in nature, thus needing energy storage to capture the excess renewable energy that's generated during the day, store it, and dispatch it during the night. My name is Karthi. I'm one of the founders here at Earth End, where we're making energy storage to do just that. But the problem is very clear, in that every single customer we talk to, namely utilities, they state needing energy storage with duration that can vary with their growth. Something that is flexible enough to run them through the entire night and that can grow with them as their renewable energy capacity increases. And a flexible and future-proof solution doesn't exist. And then current energy storage solutions are very expensive. They're very hard to scale. The majority of these technologies are not very scalable, and their majority of technologies are batteries, so they suffer from heat and cycling-based degradation, and they're also extremely unsafe with their high thermal runaway risks, which is why we've created a novel thermomechanical energy storage solution that uses carbon dioxide in a closed loop to store anywhere from 4 to over 100 hours. Now, this is uniquely flexible and future-proof in that we have our decoupled power and energy units. This is projected to be the lowest cost solution, and this is also highly scalable, because this is a 40-foot shipping container, plug and play, shipped straight to customer sites, and there is no heat or cycling-based degradation, and it's also extremely safe. At the heart of our technology, we're harnessing CO2 as a working fluid in a closed loop. As a result, we can strategically work with oil and gas to convert their CO2 pipelines in the case of CCUS hubs that are coming all over the USA and the world to decarbonize their carbon capture, sequestration, and even the grid. At the heart of our technology, we're using CO2 in a closed loop to store energy. So by 2050, when we store 100 million megawatt hours, we'll be permanently sequestering 2.7 gigatons, while on top of mitigating significantly more. Now, we recently have 3 committed pilots, one with a very large utility provider, one with an oil and gas, and one with a wind developer, in this case, Ørsted. And we recently got about $1.3 million from the Department of Energy through 2 first-of-a-kind funding mechanisms. We recently were the most promising startup out of the Houston Rice Alliance for 2 years in a row. And across our entire team, we have over 75 years of research experience and over 100 years of global operational and expansion experience. Thank you.
Good timing. Judges.
So this is basically, in principle, similar to just pressurized gas energy storage devices, but you are just doing this in a smaller scale within a TEU?
Correct. So what we're doing is we're actually using the pressurized supercritical CO2 and the hot supercritical CO2 and using the pressure and temperature delta to run our turbine. But we've configured the system in a way that it's actually for energy storage. But at the heart of our technology, it's power generation.
And what's the pressure that you guys require for these turbine systems?
High pressure is all I can say, above 3,000 PSI.
Are you right now in a prototyping phase then? Is that correct?
So we have our prototype finished, which is the 100 kilowatt system, and we have 3 megawatt, 3 pilots committed. So we're about to close our Series A and deploy those first pilots.
And if you were to look at some early economics, talk to me a little bit about what this looks like and how you make money.
Yeah, as you know, as much as I do, first of a kind fund cost economics are much higher than scale. That being said, these first systems that we're doing, they're 3 megawatt systems, and these are a little over $500 a kilowatt hour, and these are our first systems. And the nature of our technology is actually very dependent on turbo machinery. And these turbo machinery systems, these are designed for our systems, and these are supercritical CO2 systems. So the cost economics actually go way down as we get larger, and also due to the nature of the mechanical systems, they get a lot more efficient, and the cost economics in terms of margins make a lot more sense the larger you go, which is why we have so many pilots committed despite it, being at scale and cost competitiveness, just because they understand that this can really hit $50 levelized cost of storage very soon.
What is the efficiency level, closed loop efficiency level?
So the 3 megawatt system is 78% round trip efficient. That being said, we think that this can actually hit 85 to 90% at a 10 megawatt or larger. And the reason we think so is for two reasons. Number one, the system is not completely optimized yet. And number two, as just the laws of physics dictate, mechanical systems get better the larger you go. And these are, all mechanical systems, right? Rotating turbo machinery, compressors, so on and so forth. So these will perform better the larger you go. So yeah.
And how does that compare to, let's say, water gravity systems efficiency?
That's a good question. I don't know. Water gravity systems, like so hydropower or like energy vault?
Yeah, just pumping water uphill.
Yeah, I'm not too familiar. But I would imagine since those are probably impulse-driven turbines, they're probably not around the 70%, but I could be wrong.
You said you had a prototype engagement with a utility company. Is that listed here? I don't know which one it is.
So we have the prototype and we've developed it in-house. We are working to develop our first pilots with a utility provider. And that is a 3 megawatt pilot that we'll be deploying and starting to build next year as soon as we close our round.
And what's your reason for doing your factory build in Canada and EU?
We're going to do a factory build in the USA, and we're going to be starting to do that in this portion, but we're also going to be doing a factory in Canada/Europe. And the reason that we're thinking of a factory out there is because not only can we strategically work with, utility providers, commercial and industrials, microgrids, fleet charging stations, oil and gas is a really big vertical for us that not really any other energy storage company can do. And, as the DOE is funding a lot of these carbon safe hubs, and all of oil and gas is going into CCUS. The CO2 pipeline is becoming very, very attractive for all of oil and gas because it saves them a lot of money and it can unlock a whole new revenue stream. So it makes sense to have a presence out in Canada, especially in a place like Alberta, where oil and gas is very prominent, especially in a place like Europe. But I mean, these are shipping container solutions, so we can pretty much deploy and decarbonize any customer, right? So utility is the beachhead and like the lion's share of the market. But as soon as we deploy our pilots with them, we're actually going to go across the entire value chain. So EV charging stations, CNIs, microgrids, solar and wind farm owners, utilities, oil and gas are pretty much our 6 markets.
Okay, anything else? Then that should be at about our time. Thank you very much. If you will de-share, we'll bring Miss Maffezoli up next after a short scoring break. And if Alice, you can get your slides. Oh, there we go. I see you in the slides, so just a few seconds for scoring. Okay, looks like we're mostly done. So next up is Alice Maffezoli from EH Group. Please go ahead.
Good morning, afternoon, evening, everyone. So my name is Alice Maffezoli. I'm a Sales and Business Development Manager for EH Group. At EH Group, we focus on the design and manufacturing of our innovative fuel cell technology. Our objective is to displace polluted diesel generator with our fuel cell systems by solving the problem of cost and complexity in the fuel cell market. We target both stationary and mobility markets, and in general, we target large power. So starting from 20 kilowatt, but most importantly, starting from 200 kilowatt and above. At EH Group, we have redesigned fuel cell stacks at microstructural level, and the result is a fuel cell with mainly 4 advantages. So first of all, very high power density. We have more or less 2/3 of the volume and of the weight than the next best thing in the market. You can see a comparison with the other main players in the market. And then the other advantage is that we can downgrade some part of the system. So we work at low cathode pressure. So most importantly, we can downgrade the compressor inside the system. So not only the system is smaller, lighter, cheaper, but the most important thing is that we have less parasitic losses. So we have higher efficiency and less fuel consumption. The other advantage we have is that we have a lot of design flexibility. We are the only ones in the market that can go up to 300 kilowatt on a single stack platform, while the market can go up to 100 kilowatt for the moment. And then last but not least is an important cost reduction. So since 2018, we have been working on production machinery. That is a completely state-of-the-art process with rolls of raw material at the beginning of the machine and a completely assembled stack at the end of the machine in 20 minutes for a single 100 kilowatt stack. And with this machine, we plan at volume, at scale, to go to less than 100 euro per kilowatt, which is approximately less than 10% of the actual market price, which is approximately 1,000 euro per kilowatt at the moment. Since 2020, we have been deploying our stacks and systems over a large variety of applications, both in the mobility sector and in the stationary sector. So stationary, we started with some small 20 kilowatt system, and now we're working on at megawatt scale for several different applications, like data centers, construction sites, EV supercharger, cold iron, and so on. In the mobility sector, we have cooperated with a large forklift manufacturer, and we are focusing now on the maritime, aviation, and mining industry. The company was founded in 2017 by Margit Matian, who has over 20 years experience in fuel cell, and Christopher Brandon, and then the rest of the team were approximately 30, based the majority in Switzerland and a part in India. And up to date, we have raised up to 17 million euro. And we are finalizing now our Series A with the main objective to scale up, to pass from small scale production to large scale production. Thank you for your attention.
Could you explain the business model of how is this deployed, and who does what, who gets paid, or who would pay you for this?
So our main clients are in the stationary and mobility sectors. So for the moment, they are mainly system integrators. We are quite open to sell just a stack if the client can build the balance of plant himself, or we also have complete plug and play solutions. So stacks plus balance of plant. At the moment, 90% of our sales are for systems, because in the market, there is clients today, they prefer to have a plug and play solution. So they are mainly system integrator in stationary sector and mobility sector. There is a large request, mainly in stationary and maritime sectors, for complete containerized solution, which is a turnkey solution, not just with fuel cell systems, but also with cooling systems, DC-DC converters, DC-AC converters, so really turnkey solution. In this case, we also do it through some partners and to the system integration. So let's say that we offer the 3 level of product, just stacks plus balance of plant, or complete turnkey solution. I hope I answered your question.
How much revenue do you have today?
So up to date, we have had approximately 4 million.
How much?
4 million. 4 million euro.
4 million euro.
Yes.
Over how many customers?
Approximately 30 paying customers for the moment. We have a pipeline. I mean, we are negotiating approximately 150 megawatt projects with 15 megawatts at end of technical discussions, advanced technical discussion.
And what is proprietary here in what you've done? You've talked about kind of your stack design flexibility and the stack itself, but are there any kind of material innovations, or is it really kind of more the configuration that's distinctive?
So it's mainly the configuration of the stack and the way we manage the fluid inside the stack. So we have 4 patents at the moment, mainly on the core stack technology. And also we have a pipeline of 5 additional patents on the control system also, so at system level, and also on the production machinery. So production machinery is very linked to our technology. Let's say this straight to process is something that is achievable only with our technology. With the traditional technology, it's quite difficult to achieve. And this is also part of our IP.
And do you think it could be reverse engineered in a way where others could replicate this?
So it's always a risk. So we are aware of that. However, we think that as it's a completely different approach compared to the traditional technology, is not something that can be easily done. First of all, because competitors, they are following another path. And second of all, because it will take some time. We keep working on R&D, so we keep innovating. And this is our strategy.
And so really kind of your value proposition is that you feel like you're significantly lowering cost than anybody else. Is that correct?
Yes, mainly, I mean, 4 things. So technically, it's the power density and efficiency. So power density is very important when it comes to mobility application, aviation, for example. Efficiency for marine project is the key. And also, of course, cost, because at scale, we plan to arrive to less than 10% of the actual market price. But the beauty of our technology is that already at relatively low volumes, we can reach quite aggressive cost reduction. This is also the other advantage.
Can you talk a little bit about the pros and cons of the technology from a reliability MTBF standpoint?
So we started to deploy our products in 2020. We have deployed for the moment approximately 100 between stacks and systems. Of course, when we talk about lifetime, we target a lifetime of 15 to 20,000 hours. We don't have at the moment 15 to 20,000 hours, so we need time. There is something about our technology and something about the materials we use that make us quite confident in saying that this is the good number. But of course, I mean, we are a startup, so we still need time to validate these numbers. At the moment, we based everything on accelerated tests that we have done also in cooperation with the University of California, Irvine, with very successful results. And then of course, we keep deploying our systems to get data on that.
Okay, if that's it, then that's time. And thank you very much. If you can unshare, next up will be Ruben Brands. If you can share your slides while we're doing a quick, very fast. We'll take a few more seconds for the judges to score. Okay, looks like we're mostly done. So next up is Ruben Brands from CO2. Please go ahead.
Hi, my name is Ruben Brands. I'm the CEO and co-founder of CO2. Sorry for that. Our company is working on ocean-powered gigaton scalable carbon removal. In order for our planet to reach net zero by 2050, we need to reduce emissions, but that is not enough. After decarbonizing all industries, we will still need to remove 10 gigatons, often referred to as negative emissions. And that is where CO2 comes into play. But why the ocean? The key concept here is scale. The ocean already absorbs a third of all emissions, and most importantly, carbon is 150 times more concentrated than in the air, making CO2 capture easier and more cost efficient. Our solution is direct ocean capture and needs only renewable electricity and seawater as inputs. Our patented process consists of applying an electrical current to seawater, creating the conditions to strip out the CO2. Then the decarbonized water is returned to the ocean, where it absorbs an equivalent amount of CO2 from the air. The CO2 is permanently sequestered or utilized into products to decarbonize industries. McKinsey estimates that the voluntary carbon market will grow massively, reaching our 2050 10 gigaton goal. Selling carbon credits at $100 a ton would mean a $1 trillion market. We plan to reach the megaton scale around 2030 by reducing our costs as we advance our technology. Our aim is to remove 1 gigaton of CO2 from the atmosphere around 2035. And this is what our prototype looks like today, and we are leveraging it to design our pilot plant that we design now and build next year. We will deploy that in the Netherlands. We've successfully removed our first batch of CO2 and stored into concrete with our partner Pebble. We are building our pilot plant with a yearly removal capacity of 250 tons. And we generated our first revenue by pre-purchase agreements by selling 140 carbon removal credits to Klarna and World Foundation. And together with these great partners, we believe we can reach gigaton scale carbon removal in 2035. Our team brings a unique blend of technical and business expertise. So thank you for your time. And are you ready to ride this wave with us? Thank you.
Okay, judges.
How much does it cost right now for you to remove the CO2 from this, and how does it compare to the cost of the carbon credits for the 275?
Yeah, good question. So carbon removal is all about energy. So it's an energy play. We use now with our pilot plant that we deploy next year, or this year actually in 2024, we use between 3,000 kilowatt hours and 4,000 kilowatt hours. When we co-locate with an energy plant, for instance, then it's 3,000 because they are pumping the seawater to cool their processes. Yeah, so that is the main cost. So the OPEX is mainly driven by the energy costs.
And so how much is it? So for every amount of CO2 that you are capturing, what is the cost for that? And then how does that compare to the carbon credits that you are selling?
Yeah, so I calculate nowadays in the Netherlands with 25 cents a kilowatt hour. So then it's like 750 euros a ton. We are selling carbon credits. We sold carbon credits for 1,800 euros a ton to Klarna and World Foundation. That price will and must come down, of course. But yeah, there's still a margin. Yeah.
So you're manufacturing at $750 per ton.
Yeah, and that's OPEX.
Okay, and that's OPEX. Okay.
Yeah.
And how much is your pilot plant going to cost to build?
800,000 euros. Yeah.
And who are your main competitors in this market?
Yeah, so the main competitors are all the carbon removal startups out there, right? But the challenge is that big, so we don't talk as or we don't see them as real competitors. But with similar technologies, Captura in the US is working on the similar technology, and also AppCarbon, and also direct air companies or direct air capture companies like Climeworks, of course, Heirloom, those companies. Those are our competitors. Yeah.
And how are you differentiated from them?
let's say Captura is also working on direct ocean capture. They focus on membranes, and we focus on the process. And we also focused on developing a degasser that it makes it easier to do this at scale, because it's really important to do this at scale with our proprietary degasser technology. Yeah, we are able to do that.
Thank you.
Welcome.
Did you say the OpEx was $750 per ton?
With an energy price of 25 cents now, but for instance, in Norway, the energy price is like 2 cents, or even lower than 2 cents kilowatt hour. Then it's cheaper. So doing our R&D in the Netherlands makes sense because our team is here. But then we will deploy the next bigger systems in, for instance, Iceland, Kenya, Norway, where energy on the grid is green, 100% green. Energy is cheap. And also storage capacity is available in, for instance, basaltic rocks. You can mineralize the CO2 underground, and then it stays there permanently. So doing our R&D in the Netherlands with not that cheap energy is okay, but in order to scale to megaton level and gigaton level, you have to deploy our systems in countries where energy is cheap and abundant available. Yeah.
So oftentimes going from prototype to a pilot plant has a lot of challenges. What's keeping you up at night? And is there a chance that what you were building at the lab scale won't make it to the pilot plant?
No. So we chose to work with a third party for the membranes and also for the cell technology. Those are partners of ours. So there's a dependency over there. So maybe that keeps us awake at night. But they're really trustworthy. We are a spin-off company from Delft University of Technology. They are working with those companies already for like 10 years. So there's a really good relationship with those companies. And so we think we will manage, but we're dependent on those companies as well. Yeah.
And have they talked about any risks for you around the scale up? Like they're like, oh, here's one of the areas that we worry about in trying to build
those other companies, you mean?
Yes. Like that are more scale for you.
No, so their roadmaps are similar to ours. So they're scaling up exactly at the same timings at ours. And we also filed for different subsidies also in Europe, European level. And we think the story for them, the development story is quite solid. So we don't see any risks over there. They're working on the technologies that we are buying from them quite some years already. So no.
And is your cost related, or how much is electricity cost? And is that mostly used for pressurizing water?
No, so not pressurizing, but put that current on the membranes. So doing our own process, that's the main electricity usage over there. Yeah. So creating that acid side and base side with our bipolar membranes, that is taking up quite some energy.
Are these completely offshore, like a drilling plant for oil, like, or are these like on the shore?
Interesting question. So at a megaton level, I think we will deploy offshore. Now we're onshore and we're pulling in the water, or our partners pulling in the water, like energy plants. So for now it's onshore, but it makes sense to use old oil rigs, for instance, or gas rigs, and then a windmill on the side. And then capture the CO2 and put it where it belongs underground at the same time. So that would be really interesting. So we think we will do that in 2030. Yeah.
Have you talked to any of those wind turbine companies?
Wind turbine companies and also oil and gas industry. We're talking to them as well. They're really interested. They want to make a bet on this industry as well. So we have different talks with wind energy, but also and project developers, but also oil and gas industry. Yeah.
Okay. If there are no
Thank you all.
others, then we're at time, and I thank you very much. And then again, after a pause, Steve, if you can bring up your slides. Okay, I think if we're mostly set, we will proceed now with Water Warriors and Steve Chamberlain. Please go ahead.
Life cannot exist without water. We need it to survive. At Water Warriors, we believe that water is the world's most valuable resource, and we protect it by removing phosphorus from water. Because when there's excess phosphorus in water, toxic algae blooms can occur. The algae blooms make our drinking water unsafe. They're harmful to the environment as well as human health. The EPA called algae blooms one of the most costly and widespread environmental problems. So we developed Poseidon pellets through a cooperative research and development agreement with the US EPA. These pellets absorb phosphorus from water upon contact. They're chemical-free and environmentally friendly, the way we believe how water should be treated. And they're versatile, so they apply to multiple markets, anywhere from agricultural runoff on up to wastewater treatment. Poseidon pellets are a viable option. Here's an example of pellets packaged in bloom socks. In normal flows, we had about 2 minutes of contact time and reduced phosphorus concentrations by 50%. Our process is simple. We know the capacity through multiple isotherm tests with the US EPA. Once we know the phosphorus loading, we can recommend a volume of pellets to meet the water quality need. All over the world, and we're already in areas where we see high levels of phosphorus concentration and phosphorus pollution. And we're ready to make an impact with enough inventory to produce 1 million pounds of pellets and absorption capacity to capture over 60,000 pounds of phosphate. And one more thing, when the pellets reach nutrient capacity, they can be reused as a soil amendment, returning the phosphorus back to the land. And that's our mission, to take excess phosphorus where it's having a negative impact and then reuse it as a soil amendment for a positive impact. For more information, visit us at waterwarriorsinc.com. Thank you for your time.
Okay. Challenging questions from the judges.
Is there proof that, is there research on the impact of reducing phosphor alone that the water will no longer support algae blooms?
Yeah, so I mean, there's a lot of studies, about, especially when you talk about open bodies of waters, lake and ponds, lake and pond management. But the EPA has also done a lot of studies on the harmful effects of phosphorus in water. So whatever the threshold is, 0.1 milligrams per liter phosphorus, 0.2 milligrams per liter phosphorus, if you can keep, those levels below so that that food source isn't available for the algae to really bloom, when all the conditions are there, then yes, that is studies that have been done.
And what is your commercial status?
Like TRL 9.
I meant like revenue, customers' revenue.
Yeah, so we are revenue producing at this time. We have nearly 40 deployments, and we are in multiple areas all over the world.
What's your revenue total then?
So as a company, and we were founded in 2017, we've eclipsed the $2 million mark. Our initial product was a little bit different in that it was more focused on biological treatment. So, the Poseidon pellets is something that we brought to market towards the end of 2020. We did navigate through the global pandemic and have started to see sales increase year after year.
And what are, once the pellets are used, are they reusable? And how much does it cost for someone to buy it?
Right. So those are areas that we're really rolling up our sleeves and diving into now. We've partnered with the United States Department of Agriculture, and they're beginning soil studies tests so that we can make a really strong recommendation on the reuse and collecting all that data information, just like we did on the front end of understanding how, we're able to capture phosphorus from water. So as far as looking at, price points and how we kind of envision the back end of the product, I mean, we do see ag tech companies that are interested in being able to receive pellets that are high in nutrients and be able to grind them up and put them in their own proprietary blend, which is probably the path. But the cost for phosphorus in particular is always fluctuating. It is a depleting resource. So as time goes on, depending on what studies you look at, you have 70 more years left, 200 years left of being able to mine phosphate from the earth.
And your pellets, I'm assuming, are quite heavy. So where are they manufactured right now? And what is the break-even delivery radius?
So, I mean, bulk density is 38.6 pounds per cubic foot. So, that as far as from shipping, I guess is maybe what you're getting at. We're able to package them, anywhere from 5-gallon buckets to actually filled boom socks and then shipped, and then as well as super sacks. So, I think the super sack.
How much do you sell a super sack for?
I mean, it's really volume based. It depends on, what the total volume of pellets that are being purchased. But most of our sales are around $8 per pound.
Okay.
And a super sack is we use a metric ton, which 2,205 pounds.
Out of the different applications, oh, sorry, go ahead.
I was gonna ask, how much does it cost to manufacture per pound?
Yeah, that's something that I don't have those numbers.
Out of the different applications that you're serving, like the stormwater, septic, and ag runoff, so forth, what is the 2 million that you've generated mostly come from?
So our roots were really in wastewater, and most of our early kind of deployments were more in the wastewater space, whether it be municipal wastewater or industrial wastewater. Recently, we've begun to focus more in the lake and pond management space, so aquatics. So areas where we're capturing phosphorus before it gets to the larger body of water, like the lake or pond, to be able to help control the phosphorus loading. The external loading that's taking place in those bodies of water.
And you said, what was the revenue model? Is it a one-time sell? Is it recurring revenue? What's the lifespan of the pellets?
Yeah, it's recurring. And the lifespan all depends. It becomes a math equation. What's the volume of water? What's the concentration of phosphorus? And then we're able to work those numbers through the capacity that the pellets have, which we've been able to determine through the US EPA and that cooperative research and development agreement.
But the pellets are one-time use, right?
They're one-time use as far as capturing, the phosphorus from water. You do have the reuse capability for being able to use as a soil amendment. But then, yes, they would have to switch out the spent pellets with a fresh set of pellets to continue removing phosphorus in whatever the application calls for.
And what are alternative phosphorus removal technologies?
I mean, you have different methods. I mean, some are multi-million-dollar projects, especially when you're talking in the wastewater space that require infrastructure build and precipitating the phosphorus out. As far as filtration media, a lot of the medias are really just capturing the solids that might also hold some of the nutrients and claiming nutrient reduction that way. So, we feel with the Poseidon pellets, it's a very novel, innovative technology, especially when you start comparing with capacity, the porosity that the pellets have, to be able to use the entire pellet for removal, not just the outer surface.
Okay. If there are no other urgents, then we're at time. And I thank you very much, Steve.
All right, thank you.
And Steve is our last presenter today. So I'm going to go back and share this and review. We're very pleased to have had all these finalists present today. We are going to choose one winner, but all 8 of these will continue to be promoted on our website and tagged and so forth. And just quickly again, 7 Analytics, Barrow Green, BioEsol, Dynamic Air Cooling, Earthen, EH Group, CO2, and Water Warriors. So in a minute, we're going to, with this judge group, which I want to thank, we're going to disconnect the startups and have deliberation to choose one winner, but we're not going to tell them or announce that until next week, which I'll get to in a minute. I want to thank our judges again. You've asked great questions, and we're very proud of the folks that volunteer to work with XTC on this. Jaswinder Ahuja from Cadence, Dr. Vanessa Chan from the Department of Energy, Adrian Hernandez from NXP, Francis Ho from Walden Catalyst, Nicole Johnson, our liaison and progenitor of this, Global Director of Social Impact at Cadence, and Andy Cow, also a partner at Walden Catalyst. And as I mentioned before, we're going to make these guys do this 2 more times. Next Wednesday, the 10th, you're going to hear these 2-minute pitches at the XTC Cadence reception, which is a private reception for investors, more investors that they get to be exposed to at the Venetian Expo Center. And then the next day, Thursday, January 11th, they're going to be on stage at CES in the Eureka Park Tech Zone. And that is when we will announce to them and to the world who the winner is that we're choosing this week. And that is the end of our program. I thank everyone. If the judges will stay on, I will stop the recording so that deliberation is private. Thank the startups for joining, and Nancy will be in touch with you. I believe most of you are coming to Las Vegas. A couple will be on video, but one way or the other, we will see you all on Wednesday the 10th and Thursday the 11th in Las Vegas. So thank you.
Thank you so much. This is very impressive companies. Thank you. And judges for your great questions. Thank you so much.
Thank you.
Thank you, guys.
Thanks.
Thanks so much. See you in Vegas.